So any doubts to anyone in the previous lectures?
सर सर एक बार कल का ना थोड़ा सा रिपीट कर दो, मैं बाहर था ना तो ढंग से लगा नहीं पाया था क्लासेस.
So what I will do is I will quickly repeat in 2-3 minutes and I will be sending the video also, क्योंकि पूरा repeat करना तो possible नहीं होगा क्योंकि we are
Yes sir, yes sir.
lagging behind. ठीक है?
Yes sir, I understand.
So we were talking about you attended this about curved surfaces.
Yes sir.
So next to curved surfaces, we came to submerged bodies. To submerged bodies में, this was the first example. That is, in case of iceberg, only a small portion is above the free surface. And that was the reason for the Titanic accident as well. Because that's why it is called tip of an iceberg, because 92% of the iceberg remains below the free surface. Only 8% is outside. So that's why it is actually the major cause of accidents in Atlantic Sea, in Arctic seas and all those areas where there is low temperatures. So we carried out an experiment also. हमने experiment करके देखा कि we found also the same thing, that only small portion is above free surface and most of the volume is below the free surface. So this is an ice cube in water. So you can actually judge that how it is leading to accidents, because only this portion is above the free surface. So then we derived the expression for Archimedes principle, and Archimedes principle is simply the difference in pressure forces. Difference in pressure forces is called the buoyant force. That is, if pressure force on the top surface is P1A and on the bottom surface is P2A, then buoyant force is simply F2 minus F1. And Archimedes found that the magnitude of this buoyant force is actually equal to the weight of the fluid displaced by the body. So in this case, this total mass mg is balanced by the buoyant force, and the buoyant force is equal to this value, that is rho g h into a, and that is also equal to rho fluid gha. So that should be clear, and there is a mistake here. What should be here instead of h? Any clear?
Yes sir.
Because this mg is the mass of the cylinder, so cylinder is of length L, not h, and this is balanced by rho f, that is rho of the fluid, into g in h into a. So this is what we discovered, and we described the experiment that Archimedes himself was forced to do. So he was asked to find out the purity of gold. So purity of gold could be found only through if we know the density of crown, this crown. If density of crown comes out to be equal to density of gold, then this crown was made of pure gold. So to use that, he devised the Archimedes principle, and that is the weight of this, that is the weight of this crown is balanced by the liquid weight of the liquid displaced. So what he saw is, he took a spring balance, he measured the weight of the crown in air, and he found that it is V in air, W in air. And then what he did is, he took the same crown and the same spring balance and he dipped the crown in water. So now the reading of spring balance will be less as compared to that in air. So W in water is less than W in air. तो जो इसमें difference है, that is called the weight loss. And when he took a ratio of weight in air to weight loss, and that is what is weight in air? Rho crown into volume of crown into G. This is the weight in air. And what is the weight loss? Weight loss कितना होगा? Buoyant force के बराबर. And buoyant force कितना है? Weight of the liquid displaced. So what is the weight of the liquid displaced? Rho water into V displaced water into G. And you know that volume of displaced water is actually equal to the volume of crown. So when you take a ratio of these two, these cancel out and you get rho crown upon rho water. So you get to know the density of crown, Hanji, with respect to density of water. And that is the specific gravity of crown. तो उनको गोल्ड की पहले ही पता थी कि स्पेसिफिक ग्रेविटी क्या है गोल्ड की. तो he could compare whether this is coming out to be equal to rho crown or not. And that was how the Archimedes principle was discovered. Now I'm coming to today's lecture. So I have repeated some part and rest you can see in the video as well. So this principle can actually be used for determining density of unknown solids and liquids. तो आपको बहुत, मान लीजिए आपके पास कोई unknown solid है, you want to find out its density, then you can use Archimedes principle by measuring its weight in air and in water. Then you can find out the specific gravity of that material. तो specific gravity पता चल गई तो आपको density absolute भी पता चल जाएगी, क्योंकि specific gravity is density of that unknown material upon density of water, and density of water is known to you, so you can find out that density. And moreover, you can find out the volume of irregular geometries. जैसे अभी आप इंटीग्रेशन करते हो, मैं एक्सपेरिमेंटली पूछूं कि how can you find out the volume of a particular geometry. So this is the geometry and I tell you what is, find out the volume of this particular body. So the easiest way to do it is dip it in water, the amount it displaces is equal to the volume and you will get the volume of this geometry as well. Are you clear? So this is a very powerful principle. You can find out the density of unknown materials as well as you can find out the volume of irregular geometries. किसी को कोई भी doubt? Any doubts to anyone? साहित्य जिंदल, साहित्य,
यस सर.
आई डिडंट गेट योर क्वेश्चन. आप क्या कह रहे हैं एक बार, कैन यू रिपीट?
सर वो जो साइलेंडर वाला था ऊपर,
हाँ
सर इसमें एल की जगह एच नहीं आना चाहिए?
कहाँ पे?
सर आपने नीचे जब नीचे लिखा था कि यहाँ पे एच नहीं होगा, एल होगा.
हाँ
एम जी इक्वल टू रो जी एच ए.
ठीक है.
तो यहाँ पे सर एच ही नहीं होना चाहिए?
एच क्यों होना? अगर एच होता, ये आप सोच के बताओ, ये जो येलो सिलेंडर है इसका मास क्या होगा? रो ऑफ सिलेंडर इंटू वॉल्यूम ऑफ सिलेंडर.
यस सर.
तो वॉल्यूम क्या सिलेंडर का?
वॉल्यूम ए इंटू एल.
ए इंटू एल. आप समझ रहे हो?
यस सर. लेकिन वाटर डिस्प्लेस तो एच तक क्यों है?
नहीं, वाटर डिस्प्लेस एच हुआ. इसका मतलब क्या हुआ कि बुओयंट फोर्स इसके बराबर है. जितना इसने वाटर डिस्प्लेस किया उतना इस पे ऊपर को फोर्स लग रही है. ये समझ गया आप?
यस सर.
और वो बैलेंस किसको कर रही है?
रो जी एच ए को,
mg को। जो आप बात कह रहे हो, मान लो फिर तो ये होता रो जी एच ए इज इक्वल टू रो फ्लूइड जी एच ए। तो बताओ इसका मतलब तो ये होगा कि रो फ्लूइड इज इक्वल टू रो जी, जो एक्चुअल में नहीं है, सॉरी, इज इक्वल टू रो ऑफ सिलेंडर। ऐसे तो है नहीं।
यस सर, ठीक है,
ठीक है ना? तो दिस इज,
यस
so this should have been L because this is the volume of the cylinder, because you want to calculate the mass of the cylinder.
यस सर, ठीक।
So a closely related concept which you have asked is this. तो अगर density material की less than fluid है, so it will float. If it is greater than fluid, it will sink. तो इसका मतलब क्या हुआ? buoyant force sufficient नहीं है उस चीज को यहां पे सस्पेंड करने के लिए। यानी क्लियर है? So this is called floating body. This is called neutrally buoyant body. तो ये बहुत स्पेशल वर्ड है. This is called neutrally buoyant body. And this body is what is being going at the bottom because buoyant force was not sufficient. तो इसको कौन कौन सी फोर्सेस सपोर्ट कर रही होंगी?
सर एक इसका खुद का वेट होगा और एक फ्लूइड की तरफ से
इसका डाउनवर्ड डायरेक्शन देखो। अगर मैं इसको बोलूं, अगर ये एक तो mg इसको नीचे लग रहा है, ठीक है, इस फेस पे कुछ प्रेशर फोर्स लग रही होगी F1, और क्या होगा, यहां पे प्रेशर फोर्स लग रही होगी F2, और क्या होगा, इसका नॉर्मल रिएक्शन भी लग रहा होगा N।
यस सर,
ठीक है ना? तो ये N इसको यहां पे बैलेंस कर रहा है क्योंकि ये दिस इज इन स्टैटिक इक्विलिब्रियम। इसका मतलब क्या हुआ? सम ऑफ ऑल फोर्सेस शुड इक्वल टू 0। तो उसका यही मतलब हुआ कि buoyant force प्लस दिस रिएक्शन फोर्स बोथ आर बैलेंसिंग दिस mg मास। यानी क्लियर है? किसी को कोई भी डाउट? यानी क्लियर? Now I am showing you certain experiments which are carried out, and this will help you to appreciate how Archimedes principle goes when it is in real life operation. So this was a component which I measured using a spring balance, and this came out to be around 800 grams. So 0.5 means basically it means 500 grams. So this is 0.5 kg, 0.5 kg. So this is 1 kg. So it means this is 800 grams or 0.8 kgs, what is being shown. Now when I immerse this in liquid, the weight, the spring balance measures only 600 grams. So 200 grams is actually nearly the weight loss. And this should actually equal to what? Buoyant force. और ये किसके बराबर होना चाहिए? वेट ऑफ द लिक्विड डिस्प्लेस्ड। तो आप घर पे भी एक्सपेरिमेंट कर सकते हैं। तो मैंने इसको देखा कि इसका वैसे वेट 785 ही तकरीबन है, जैसे जो 800 आ रहा था। तो आप ये देख सकते हैं कि ये पहले ये लेवल था, डिप करने के बाद ये लेवल रह गया। तो आप इस डिस्टेंस को मेजर कर सकते हो। इसका एरिया पता है आपको, तो फ्लूइड डिस्प्लेस्ड की वॉल्यूम आ जाएगा, इनटू रो ऑफ फ्लूइड करो तो ये buoyant फोर्स इंटू जी करो, ये buoyant फोर्स के बराबर आ जाएगी, और ये अराउंड 200 इंटू जी आएगी बेसिकली। So you can verify Archimedes principle at home as well. Now this was another experiment which will clarify further what is meant by floating bodies and what is meant by bodies which sink. तो मैंने क्या किया? This is an empty bottle of glass which contains air. So you are able to see this is actually taking a particular inclination. Now let me know, if you disturb this a little bit, will it change its orientation or will it come back to this orientation only?
It will come back to its orientation.
It will come back to its original orientation. तो इसमें आप सोच सकते हैं ये ऐसी ओरिएंटेशन क्यों है, पहले ये बता सकते हैं? ये हॉरिजॉन्टल क्यों नहीं हुई, वर्टिकल क्यों नहीं हुई?
वो दो डिफरेंट मटेरियल है, दोनों की डेंसिटी अलग अलग है।
हाँ, तो आपको क्या लग रहा है इसमें किसकी मटेरियल की डेंसिटी ज्यादा लग रही है आपको?
जो ब्लैक वाला है उसकी डेंसिटी
तो
ज्यादा
इसकी
होगी।
डेंसिटी हायर है, तो दैट्स व्हाई दिस हैज टिल्टेड इन दिस डायरेक्शन। हाँ जी, क्लियर है? तो दिस वाज अराउंड 16 ग्राम्स। तो मैंने उसके बाद नेक्स्ट एक्सपेरिमेंट किया, आई फिल्ड दिस एम्प्टी बॉटल विद सम वाटर। नाउ यू कैन सी, now the preferred orientation is in this direction and some portion is outside the water. So this is the free surface and this portion is outside water. So this is the case of a floating body, and the previous case was also a case of floating body. Clear? Now depending on, अब मुझे बात बताइए, इस पूरी बॉडी की डेंसिटी अगर मैं बोलूं रो बी, दिस शुड बी लेस देन, ग्रेटर देन और इक्वल टू रो वाटर? Less than. So please remember, when you see a ship also, ship is although made up of steel, स्टील की डेंसिटी वाटर से बहुत हाई है, लेकिन हम डेंसिटी स्टील की नहीं लेते, उसमें पूरी शिप की लेते हैं जिसके अंदर एयर भी है और मटेरियल्स भी हैं। तो जो रो ऑफ शिप है, इसको इफेक्टिव लिखूं, रो इफेक्टिव ऑफ शिप, दैट इज लेस देन रो वाटर, देन ओनली शिप कैन एक्चुअली फ्लोट। क्योंकि स्टील अगर होती सिर्फ उसके अंदर, देन इट वुड हैव सिंक इन द वाटर. So that should be clear. So when I talk about density, it means density of the entire body, and which may also be variable. जैसे इस केस के अंदर इस पार्ट की डेंसिटी कुछ और है, इस पार्ट की कुछ और है, इस पार्ट की कुछ और है डेंसिटी. So this is a varying density kind of body. अब यहां पे आप देख रहे हैं, if you are careful in your observation, 16 grams में ऐसे था when it was empty. I filled it with some water, it became 22 grams. Now in which case, now this is 22 grams, and the third case is I have further filled this with more water, that is 26 grams. So what happens? It again floats like this. I again filled it with more water, say 29 grams is the total weight. Now you are able to see this is just, this surface is just touching the free surface. So this is also a, you can call this as a floating or submerged body. So this is just floating. So it can be called as submerged because all the part is below the free surface. Are you clear? So here at this position, buoyant force and weight of the body are being balanced in this orientation. Likewise in the previous cases also. हाँ जी,
हेलो सर.
हाँ जी
सर, जो 29 ग्राम्स वाला केस था,
हाँ जी,
उसमें सर ये कह सकते हैं कि जो डेंसिटी ऑफ बॉडी इज ऑलमोस्ट इक्वल टू डेंसिटी ऑफ वाटर.
यू कैन कॉल, बट इन दैट केस क्या होना चाहिए था, मान लो इसको मैं नीचे लेके जाऊं, अगर इस बॉडी को नीचे लेके जाऊं, अगर डेंसिटी सेम होगी तो क्या होगा?
इक्विलिब्रियम रहेगा.
तो वो उसको, जैसे मान लो इसको मैं यहां ले जाऊं तो यहां पे भी रहना चाहिए उसको,
Yes, sir.
ठीक है, तो जो आप न्यूट्रली बॉयंट बोलते हो उसमें क्या है कि मैं बॉडी को कहीं भी ले जाऊं वो वहीं पे स्टेबल हो जाए। अगर वो वापस इस लोकेशन पे आ रहा है इसका मतलब वो न्यूट्रली बॉयंट नहीं है, उसकी डेंसिटी क्या है, लेस देन रो फ्लूइड। हाँ जी, क्लियर है? आई विल शो यू वन small video also. Now this is when I have filled it with 30, with the total weight is 32, so it completely sinks because here density of body is greater than density of water. And clear hai? Any doubts to anyone? किसी को कोई भी doubt? So wait for a second, I am showing you a clip that will clarify the concept more. So are you able to see the video? Are you able to see the video?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
So try to see, I have disturbed its equilibrium position, it is coming back. So what is pushing this body up? Try to see, the body is moving up on its own.
So the buoyant force is pushing.
So the buoyant force is pushing it up, and wherever it finally gets stable, at that point or at that location, buoyant force becomes equal to mg. And you clear है? अगर ये वापस ना आती तो वो न्यूट्रली बुओयंट होता, वो जहां पे भी रखते वहीं पे रहती वैसे ही। हाँ जी, क्लियर? किसी को कोई भी डाउट? ये लैंडस्केप हुआ हुआ है, प्लीज डोंट कंफ्यूज, ये एक्चुअल में वीडियो में आपको पोर्ट्रेट में देखना चाहिए बेसिकली। Any doubts to anyone? Again, wait for a second. This is another which will clarify your concepts. Now this is a body which is again submerged. Now try to see, I am trying to disturb its orientation. So I am making efforts कि उसकी orientation को मैं change कर दूं, but it is restoring back its orientation. So what is making it restore its orientation? अब ध्यान से देखिएगा, I have tried to see. Now it has risen up. Why it has risen up? Now it is going back because it was not stable at the higher level. लेकिन वो ऊपर राइज इसलिए किया क्योंकि उस पे बुओयंट फोर्स और ग्रेविटेशन का एक टॉर्क लगा जो उसको ऊपर ले गया, लेकिन ऊपर वो स्टेबल नहीं था एंड इट केम बैक अगेन। एंड क्लियर है? एनी डाउट्स टू एनीवन? And now one last video that is regarding floating bodies. So this is if some part is above the free surface. So now I am trying to disturb its equilibrium position. Now try to see, it is again restoring its orientation. Whatsoever effort I do, I am not able to disturb its orientation. It is restoring back its own orientation. हाँ जी, अब मुझे इसमें बताइए किस केस में मैं इसको सिंक करवा सकता हूं?
सर इसको कंप्लीटली वाटर से, लिक्विड से फिल कर दीजिए।
नहीं, मान लीजिए इसी को मैंने करवाना है तो मैं कहां पे वेट रखूं? दिस इज जस्ट लाइक अ शिप। आप इसको शिप मान लीजिए, ये शिप है, यहाँ पे शिप अभी सेल कर रही है, दिस इज अबव फ्लूइड फ्री सरफेस। तो इस पे जो मैं मास लगाऊं वो कैसे लगाऊं ताकि ये सिंक कर जाए?
Sir, on top of it.
On top of it. So we will now
Inclined.
see how that happens. So any doubts to anyone? Floating bodies, submerged bodies, and the bodies which sink. So what happens is, what you can see is, in case of ships, this is center of gravity, G. This is center of buoyancy. So what is center of buoyancy? So how will you define center of buoyancy? Anyone? किसी को can you define in your own words center of buoyancy क्या होगा basically? सेंटरॉइड या सेंटर ऑफ ग्रेविटी तो हम बोलते हैं कि जहां पे सारा मास कंसंट्रेटेड है। तो व्हाट डू यू
जहाँ पे सारा buoyant force बैलेंस्ड है,
जहां पे
buoyant force और weight बैलेंस्ड है।
नहीं, सेंटर ऑफ बुओयंसी मतलब बी का मतलब क्या है? ये पॉइंट ढूंढोगे कैसे? जैसे अगर मैं बोलूं ये रेक्टेंगल है मेरे पास, so this is rectangle, I ask you where is the centroid, so you will say here is the centroid, ठीक है ना? आप इसको सेंटर ऑफ ग्रेविटी बोल देते हो अगर ये वॉल्यूम है। नाउ माय क्वेश्चन इज, center of gravity means all the mass is assumed to be concentrated at a point. Now what do you mean by buoyant center of buoyancy?
हेलो सर।
हाँ जी, हाँ जी बताइए, हाँ जी बताइए। हेलो, आपकी आवाज नहीं आ रही।
वॉल्यूम का सर वो है सेंटर मतलब।
हाँ, तो डिस्प्लेस्ड वॉल्यूम का सेंट्रॉइड होगा। डिस्प्लेस्ड वॉल्यूम का जो सेंट्रॉइड होगा दैट इज सेंटर ऑफ बुओयंसी। हाँ जी, क्लियर है? हाँ जी, एनी डाउट्स? तो मुझे बात बताइए, क्या सेंट्रॉइड ऑफ डिस्प्लेस्ड वॉल्यूम या सेंटर ऑफ बुओयंसी मटेरियल पे डिपेंड करेगा कि नहीं करेगा, या सिर्फ ज्योमेट्री पे करेगा? सेंटर ऑफ बुओयंसी विल डिपेंड ऑन,
सर ज्योमेट्री पे डिपेंड करेगा,
ओनली ऑन ज्योमेट्री। तो प्लीज रिमेंबर, चाहे आपने ये स्टील है, चाहे ये वुड है, कुछ भी है, अब इस केस में इतना डिस्प्लेस्ड, दिस इज द वॉल्यूम ऑफ डिस्प्लेस्ड, so this is the volume that is within the liquid, that is the volume which has been displaced by this body, and in this case this was the volume that was being displaced by the ship. So whether material here is wood, steel or any material, it does not matter. Center of buoyancy will always lie at this point. हाँ जी, क्लियर है? Any doubts to anyone? Now what happens is, as we saw in the experiment also, तो अब दो पॉइंट्स तो क्लियर है, किसी को कोई डाउट? सेंटर ऑफ ग्रेविटी एंड सेंटर ऑफ बुओयंसी। सो सेंटर ऑफ ग्रेविटी डिपेंड्स ऑन मटेरियल, सेंटर ऑफ बुओयंसी डिपेंड्स ऑन ज्योमेट्री और द वॉल्यूम, ज्योमेट्री ऑफ द वॉल्यूम डिस्प्लेस्ड।
the center of gravity will depend on both, right? Material and geometry.
Center of gravity will depend, but for a given body.
Yes sir, obviously.
For a given body, G will be a constant.
Yes sir, yes sir.
So for in this case, G is a constant. G is not varying at all. But will be the location of B change? if say the ship tilts to this direction. So there is wind blowing in this direction, or something struck this ship in this direction, and ship tilted a little bit in the right side direction.
No, sir.
So will the G location change? G location will not change. So please don't confuse this with this. These are two different ships. अगर आप ये tilt कर रहे हैं इसको, you are tilting this, what will happen only? G location will not change, because G location किस केस में चेंज हो सकती है? इस शिप में भी G लोकेशन किस केस में चेंज हो सकती है? मान लीजिए यहां पे कोई सामान पड़ा था, and due to movement this got shifted somewhere else, then G can change. Otherwise location of G will never change. हाँ जी, clear है? Any doubts? But the location of center of buoyancy will shift towards right. वो क्यों? क्योंकि अब वॉल्यूम का ज्यादा पोर्शन टूवर्ड्स राइट है जो डिप्ड है. So B will shift from a location this to right side. Likewise, this is also the same case, but to find out whether the ship will topple or there will be some restoring torque, as we saw in the experiment, वो किस पे डिपेंड करेगा? That will depend on this coordinate M, that is called the metacenter. So metacenter is the point of intersection of the line of action of buoyant force before, this was the line of action of buoyant force before the torque was applied, and this was the line of action after the torque was applied. So wherever these two lines of action meet, that point is called the metacenter. And the distance from center of gravity to metacenter, that is GM, is called the metacentric height. So try to see, now let me know if, in which case will the ship sink. I'm writing down two things here. GM is greater than 0, GM is less than 0, or M is lying above G, and in one case G is lying above M, and third case is say G and M are, this will never happen, but so I am not taking this case. So in which case the ship will not topple? In which case the ship will not topple? किस केस में शिप नहीं डूबेगी? हाँ जी, हेलो
सर, जब GM हमारा ग्रेटर देन 0 होगा.
GM is greater than 0 और M is lying above G.
Yes sir.
ठीक है. So this is the criteria for stability of floating bodies. So please remember this for a body, because in this case when M is above G, अगर कोई tilt कर भी रहा है, so there is a restoring torque which restores the ship back to its original stable position. लेकिन अगर M G से नीचे है, then there will be no restoring torque, but on the other hand there will be a torque which will help to further topple the ship. So that's why please remember, इसमें आपके कंट्रोल में क्या है शिप के, what is in your control? You want M to be greater than always over B. How can you do that? Or you know that GM should be greater than 0. So what is in your hand so that this is ensured?
Weight of ship.
Center of gravity. So you will tend to keep all the heavy material below this free surface. So that's why all the propellers, engines, and most of the luggage, you keep it here. Otherwise, and that ensures that G is a little bit lower, because in this case, if G would have been somewhere here, then also this would have been stable. Because we don't have that much control over B, we can control actually G. So always try to reduce the height of G. The lower the location of G, the better is the stability. Are you clear? Hai? Any doubts to anyone? So like in case of floating bodies, we also have stability in case of submerged bodies. So submerged bodies mean bodies which were totally submerged. Say this was the example which you have already seen. So this was a fully submerged body. So what do you see? अगर आप इस ब्लैक पोर्शन को ऊपर करने की कोशिश करो तो क्या होगा? It will come back to this stable location. So it is overturning. So it is not stable. So that's why what you see here is, so in this case, let me know first whether the center of buoyancy and center of gravity, they are coinciding, or they are, which one is above, which is one is below. So where will be the center of buoyancy? What do you think? This is a cylinder that is fully submerged. So this is of height h. So where do you expect the center buoyancy to be?
Near the black cap.
Center of buoyancy. Center of buoyancy depends only on geometry. So where will be the center of buoyancy? Where will be the center of buoyancy? एक सिलेंडर का सिलेंडर पूरा इमर्स्ड है, तो डिस्प्लेस फ्लूइड भी सिलेंडर है, तो डिस्प्लेस फ्लूइड h/2. So center of buoyancy will be at h/2. Where will be G?
सर ब्लैक सरफेस के पास.
Black surface के पास, that is below. If this is say B, center of gravity will be somewhere here.
Yes, sir.
Because water is also filled up till this location only. So center of gravity will be somewhere here. So B is above G and this is stable. अगर आप इसको उल्टा कर देते, then this will not, मान लीजिए आप इसको मैं ऐसे लोकेशन पे कर देता हूं, say this has been tilted. So location of B will change or not? Location of B or G will change or not? Floating bodies में B and G, this B changes because displaced fluid different हो जाता है, इस साइड ज्यादा displaced हो गया. मैं ये पूछ रहा हूं सबमर्ज बॉडीज में क्या B और G सेम लोकेशन रहती है कि चेंज हो जाएगी? G will not change G can change or G will not change?
Sir,
will
G
not
will change.
G will change because water here will take some different configuration. Say G has changed a little bit. Say this is G. B will change or not?
No, sir.
No. So what will happen? This is up and this is down. What is happening?
सर
It
मेरी
will
कहना सर
restore.
कि हेलो
हाँ जी.
सर बी से नहीं चेंज हो रहा है ना इसमें भी कि वाटर डिस्प्लेस नहीं हो रहा है कोई भी टिल्ट होने पे
नहीं, वाटर डिस्प्ले जितना पहले था उतना ही अभी है, उसमें तो चेंज नहीं आ रहा है.
वही चेंज नहीं हो रहा है
हाँ, तो बी की तो लोकेशन चेंज बिल्कुल ही नहीं हो रही और जी की भी लेफ्ट और राइट नहीं होगी, वो सिर्फ क्या होगा, थोड़ा सा पॉइंट बी के नजदीक आ जाएगा. So then also there will be restoring torque. So here was B. So buoyant force was acting in this direction. Here was G. This was mg. So this is a torque that wants to bring it back to the vertical orientation. So for stability, B should always be above G. And for the special case of neutrally buoyant means when the density of the liquid and the body are same, then B and G coincide. And in the unstable case, you also know that if G is lying above B, so what will happen? Say G is lying above B. So this was G, this was B, say. So what will happen? So this will overturn this. So there will be no restoring torque. There will be overturning torque. And that's why this is called unstable equilibrium. So please remember, all the three states are in equilibrium, but one is stable, one is neutral, and other is unstable. So you can understand with these three terms as with the help of this diagram. Stable means if you bring this ball here, it will come back to its original location. Likewise in this direction. Neutrally buoyant, neutrally stable means यहां भी stable है, move करके यहां भी पहुंच गई तब भी वो stable है. So wherever it is stable. And unstable means if you give certain disturbance in either of the two directions, it will never restore back to its original location. So that is called unstable equilibrium. So all the three are cases of equilibrium, but now we are to be careful what is stable equilibrium, what is neutrally stable equilibrium, and what is unstable equilibrium. Any doubts to anyone? किसी को कोई भी doubt? Now let me know if this is a helium balloon or hot air balloon, why it is rising in air?
सर क्योंकि हीलियम की डेंसिटी नॉर्मल एयर से कम होती है.
So it means buoyant force is greater than mg.
Yes.
So what do you expect? Will it stop somewhere?
Yes, sir.
So at that location, what will happen? Buoyant force will become equal to mg. And clear hai? And this is the end of fluid statics. And these are the two contradictory diagrams which I want you to answer to. In first case, these are needles that are floating on the free surface, and these are made of iron, and we know that rho of iron is far more than rho of water, and it is also not displacing any water. So why they are floating?
सर पानी का सरफेस टेंशन जो है वो उनको सिंक नहीं होने दे रहा.
So you are correct. So here there is surface tension force. So please don't confuse this with buoyancy. These are two entirely different concepts. Here nothing is to be done with how much water is being displaced by the body. So please remember that. So don't confuse surface tension effects with buoyancy effects. Now what about this? What is holding the water column? So this is a small paper and the entire water column is resting on this small piece of paper. I have not attached any kind of adhesive or anything like that. What is balancing this height of water? This is simply a small piece of paper.
एटमॉस्फेरिक प्रेशर, पानी का प्रेशर एटमॉस्फेरिक प्रेशर से कम है तो वो पेपर ऊपर की ओर पुश हो रहा है.
Okay, so you are again correct. So atmospheric pressure from beneath is holding this water column. And my follow-up question is, what do you expect? कितना maximum column ये bear कर सकता है? I leave it this as an exercise for you. Any doubts to anyone? Any doubts to anyone? So I'm done with fluid statics.